Hello fellow embedded heads! In this video I'm going to show you how to figure out the required adapter, wiring, pinout, and configuration in order to physically connect your SEGGER J-Link debug probe to a target device. If you're working with a SEGGER Flasher in System Programmer, please check out this video instead. For links and hints, please see the description below. If you're enjoying this video, please like and subscribe. Let's get started. The first step is to make sure your target device is supported by the SEGGER J-Link and to the required extent. You can do that by visiting segger.com, hover over Products, and then click on Debug. Click on Supported Devices in the page menu. Type in the part number of the target device you need to debug and hit Enter or click Submit. If you see your target device in the list and you have a check mark in the column for J-Link, you're off to a good start. Note that for a lot of devices, especially from the major manufacturers, SEGGER has created knowledge base pages for the associated device families. If there is no knowledge base page for your device, skip this step. You can click on this link to get to the knowledge base page to see additional important information about the provided support. For example, you can see which internal flash banks the J-Link can program on your device. This is important for being able to debug your application from internal flash using J-Link. You can also see if indirect programming of external serial NOR flash, like QSPI flash, that might be connected to your device is supported, and if so, in which configurations. Note that if there's no mention of QSPI flash here, then this usually means that indirect programming of externally connected QSPI flash is not supported for this device, at least not yet. If this is something you need, or if an internal flash bank you need to program is not listed, you need to contact SEGGER. As an aside, the information on these device family knowledge base pages is very useful overall, so keep them in mind. After you have established that your device is sufficiently supported, make sure you download and install the latest J-Link software and documentation pack from the SEGGER website under Downloads, J-Link/J-Trace. This software pack gets updated frequently, so if you are working with an older version of the J-Link software pack, it might not yet support your target device, or it might not support the latest features. Therefore, make sure you're always working with the latest version. On the left, you can find the release notes, which can come in handy sometimes. On the right, you can see the available installers. The J-Link software pack is available for multiple different combinations of host OSs and host architectures, so make sure you download the correct installer for your host computer. Helpful hint: if for whatever reason you are ever in need of an older version of the J-Link software pack, you can access any older version back to version 5 by using this pull-down menu here. Next, check the documentation, specification, or schematics for your target board and figure out the intended way of connecting to the target device in order to program and debug it. Note that many circuit boards these days have multiple devices on them. Make sure you identify the correct access point for each of them so you don't accidentally try to connect to the wrong target device on the board. For Arm Cortex-based devices, some of the most common debug interfaces are SWD, JTAG, or CJTAG. The most common debug connector carrying these debug interfaces is the 10-pin 0.05-inch pitch connector as defined by Arm. This is the associated pinout using SEGGER J-Link terminology. Pin 7 is supposed to be missing in order to accept a key from the cable to be plugged in. But very often you see this connector having all 10 pins. Pin 7 is just not connected in this case. Make sure your target board feeds the target device's voltage supply level back to the J-Link on pin 1, which is the target reference voltage pin called VTREF. This sometimes misunderstood pin is an input pin used by the J-Link to check if the target board has power, to create the logic level reference for the input comparators, and to control the output logic levels to the target device, so this is quite important. Note that there is a way to configure the J-Link to assume a certain fixed target voltage level and ignore what it measures on the VTREF pin. for example via the J-Link Commander or the J-Link Configurator utilities. This is a very helpful workaround just in case the VTREF pin is not connected in your design. If your target board has the 10-pin Arm Cortex Debug connector, then the SEGGER 9-pin Cortex-M adapter will allow the SEGGER J-Link to access the target device via SWD, JTAG, or CJTAG, depending on what your target device/target board combination supports. Connect the 9-pin Cortex-M adapter to the J-Link as well as the debug connector on the target board. Sometimes the connector is keyed, sometimes it's not. If it is not keyed, watch out for the correct orientation. The red wire of the ribbon cable needs to connect to pin 1 of the connector. Also make sure the cable header covers both rows of the connector. Sometimes you also see a 20-pin version of this debug connector, which was also specified by ARM. The associated pinout from a SEGGER J-Link reference point is shown here. Note that pins 1 through 10 correspond exactly to the 10-pin version we just talked about. The full version of this connector also carries a trace clock pin and 4 trace data pins, which are used for instruction tracing during advanced debugging, for example when using a SEGGER J-Trace probe. But the SEGGER J-Link does not use these pins, therefore they are not relevant. Again, pin 7 on this connector is supposed to be missing in order to accept a key from the cable to be plugged in. But very often you see this connector with all 20 pins. Note that when using this connector, you have the option to configure the J-Link to power the target board up to 400 mA using pin 11 and/or pin 13 if your target board is designed accordingly. The J-Link is only able to output 5 volts on those 2 pins. However, SEGGER offers various target adapters that allow you to supply your target board with voltages other than 5 volts if required. Of course, you can also apply power directly to your target board and not power the board via the J-Link. No matter how you are powering your target board, make sure your board feeds the target device's voltage supply level back to the J-Link on pin 1, the VTREF pin. Please remember that the pinout shown here is the pinout of the connector on the target board. It is not the pinout at the J-Link 20-pin target connector. If your target board has the 20-pin Arm Cortex Debug Trace connector, you can connect to the target device via SWD, JTAG, or CJTAG using the SEGGER 19-pin Cortex-M adapter. Connect the 19-pin Cortex-M adapter to the J-Link as well as the Debug and Trace connector on the target board. Again, if the connector is not keyed, watch out for the correct orientation. Make sure the red wire of the ribbon cable is connected to pin 1 of the connector and that the cable header covers both rows of the connector. To save cost and space, some target boards don't have an actual connector for debug access. Instead, these boards may have a footprint with 10 contacts for a needle adapter. This is the associated pinout using SEGGER J-Link terminology. As before, watch out for the VTREF pin and note the optional 5-volt supply pin. If your target board has a footprint like this, the SEGGER 10-pin needle adapter will allow the SEGGER J-Link to connect to the target device via SWD, JTAG, or CJTAG. The 3 locating pins ensure that the adapter cannot be connected to the PCB the wrong way. In addition, the 2 clips on each side of the connector guarantee a stable and secure contact between the pins and the PCB. If your PCB doesn't have the holes required for the clips, you will need to cut off the clips and hold down the adapter by some other means during debugging, which is obviously not ideal. There's also an even smaller 6-pin version of this type of connection. The associated pinout is shown here. Note that there is no 5-volt supply pin in this 6-pin version. Also note that a regular JTAG connection to the target device is not possible using the 6-pin adapter. If your target board has a footprint like this, the SEGGER 6-pin needle adapter will make sure the SEGGER J-Link can connect to the target device via SWD or CJTAG. Just like with the 10-pin version, the 3 locating pins ensure that the adapter cannot be connected to the PCB the wrong way. Some target boards still have an older 20-pin 0.1-inch pitch debug connector as specified by Arm. This is the associated pinout using SEGGER J-Link terminology. For this particular connector, the pinout of the connector on the target board is actually the same as the pinout at the J-Link 20-pin target connector. If your target board has a header like this, then you can directly connect the SEGGER J-Link to your target board using the included 20-pin ribbon cable. But what if your target device requires a debug interface other than SWD, JTAG, or CJTAG, or your target board does not offer any of these described standard ways to connect to the target device? In this case, you can browse the large selection of SEGGER debug adapters to see if one of them fits your needs. To find the debug adapters, go to segger.com, hover over Products, and select J-Link adapters. You can scroll through the page to see the various adapters. You can also hover over Accessories, Adapters for a list of the available adapters. You will find adapters that are specific to devices from certain silicon vendors like TI, Renesas, Infineon, Microchip, etc., and their proprietary debug interfaces. Others adapt to different kinds of target connector form factors or pinouts. Some adapters provide different options to supply power to the target board, smoothen signals, or provide measurement capabilities. Maybe the most universal adapter is the so-called flying wire adapter. It allows connecting the J-Link to target boards via individual wires. This is especially useful when connecting to boards without a dedicated debug connector, or to prototype hardware where no final connector is decided yet. In the SEGGER knowledge base, there is additional information about the pinout of the 20-pin connector on the J-Link. This page has the pinout for SWD, JTAG, CJTAG, SPI, and Quad SPI, as well as target board design recommendations. The link to this page can be found in the description below. Note that the pinouts that are shown are valid when looking straight at the 20-pin connector on the J-Link. If you have a serial NOR flash, like a QSPI flash, that you need to program directly via SPI, meaning without an MCU in between, be sure to check out the SEGGER J-Flash SPI tool. Since the J-Link communicates directly with the QSPI flash in this case, even flash memories connected to MCUs that are not supported by J-Link can be programmed. The J-Flash SPI webpage shows the J-Link 20-pin connector pinouts that apply to SPI and QSPI flashes, as well as the pinout of the footprint on the target board when using the 10-pin needle adapter. The list of supported SPI flash memories can be found on this page. One other thing related to the J-Link connector pinout is worth mentioning. The SEGGER J-Link allows the connected host computer to communicate with a UART on the target device via a virtual COM port. This can be helpful for exchanging information with the target device during debugging. With the VCOM port enabled, the target interface of the J-Link looks like this. If you want to use the VCOM port feature, the target board needs to be designed in such a way that the receive pin of one of the UARTs on the target device is routed to pin 5 of the J-Link, and the transmit pin of the same UART is routed to pin 17 of the J-Link. Note that a full JTAG connection is not possible when using the VCOM port. More details can be found on this page. You can find the link to this page in the description below. After you have identified the correct way to connect the J-Link to your target board, you can start using J-Link for debugging in your software development environment, meaning your IDE, your graphical debugger, or your command line interface. J-Link is supported by the majority of IDEs and development environments in the embedded space. 3 tools from SEGGER that pair up extremely well with J-Link are the Ozone Debugger and Performance Analyzer, the System View Real-Time Recording, Visualization, and Analysis tool, and the Embedded Studio Cross-Platform IDE. Of course, you can also start using all the other helpful SEGGER software tools and utilities from the J-Link software pack, like J-Link Commander, J-Link Configurator, J-Link Remote Server, and so on. If you have any trouble establishing a connection to the J-Link or to the target device, be able to check out this SEGGER knowledge base page, which has some very valuable troubleshooting tips. You can find the link to this page in the description below. And there you have it, fellow embedded heads. Now you know how to physically connect your SEGGER J-Link debug probe to a target device. Because SEGGER J-Links are so flexible, and due to the large variety of supported target devices, we were not able to cover all use cases in this video. However, we still hope you found it useful. So if you enjoyed this video, please like and subscribe. Please also make sure to leave comments below. Thanks for watching.